This is Rambod. In this tutorial, you'll learn how to create static utility functions in C++ that are instantly available in every blueprint. If you want powerful global nodes without extra setup, subscribe and let's get started. In any Unreal project, blueprint only or full C++, you can still create new C++ classes. Let's add our utility library. Open the Tools menu at the top and choose New C++ class. The class wizard appears. Switch to the All Classes tab so we can search every parent type. In the search box, type Blueprint Function Library. The result called Blueprint Function Library is exactly what we need for global static nodes. Select it and click Next. Unreal suggests the file name My Blueprint Function Library. That's fine for this demo, so leave it as is. Press Create. Unreal generates the header and source files and starts a compile. When the compile kicks off, your chosen IDE opens the new files. I'm using JetBrains Rider, the free non-commercial edition, because its code analysis and hot reload support are excellent. After the build completes, we have an empty class stub. No functions yet, just the framework will extend. Up next, we'll write our first helper method and watch it appear inside any blueprint graph. Now let's add our first utility function to the header file. First, I type the word public. This makes everything after it accessible from outside this class. Next, I'll add the function declaration for removing extra spaces. I've already prepared this code, so I'm pasting it here for efficiency. Let's break it down. UFUNCTION is an Unreal macro that tells the engine to expose this method to blueprints. When I use BlueprintPure, it means this function does not change anything in the game world. It only reads data and returns a result. In blueprints, this node will be purple and won't have execution pins. Category lets us organize our function in the blueprint node search. Here, it will appear under Rambod dev, then utility, then string. Next, I declare the function as static. That means it belongs to the class itself and I don't need to create an object to use it. The function returns in string, which is Unreal's native string type. The parameter is a constant reference to a string called input string. This way, we can pass any string from blueprints and get a cleaned up version back. Now, let's add another function below it using the same approach. I'll paste in the declaration for reverse words. This one is almost identical in structure. It will take a string and reverse the order of its words. The comment above the function will show as a tooltip in the blueprint editor, helping anyone who uses this node understand what it does. After adding both declarations, I right-click on each and choose Generate Definition. This tells the IDE to make empty function bodies in the CPP file for us. Switching to the CPP file, I need to add a special include at the top. Double quotes, algo reverse.h, double quotes. This header gives us a helper function for reversing arrays easily. Now let's fill in the logic for remove extra spaces. I start by creating an empty string called cleaned and a boolean called last was space set to true. I loop over every character in the input string. If I find a white space and the last character was not a space, I add a single space to the clean string. If the character is not white space, I copy it to the result and reset the flag. Finally, I call trim start and end to remove any extra space from the beginning or end of the string before returning it. Next, I move on to reverse words. The first thing I do is call remove extra spaces to make sure the input is tidy. I split the clean string into words using parse into array. Then I use algo reverse to flip the order of the words. I join them back together with a single space using string join and return the result. Once both functions are filled in, I save all files and click Build. If there are no errors, Unreal now knows about our new nodes. In the next part, I'll show you how to use them inside a blueprint graph. With the project built, it's time to test our new static blueprint functions right inside Unreal. First, I open the level blueprint. You can do this by clicking the Blueprints menu at the top and choosing Open Level Blueprint. Inside the blueprint graph, I want to test the function when I press a key, so I right-click on an empty space and search for input key W. This node will fire an event every time I press the W key during gameplay. Next, I want to find our new utility functions. I right-click again and scroll through the list of blueprint nodes. You'll see a new category called Rambod dev. This folder exists because of the category we set in our C++ code. I open Rambod dev, then utility, and then string. Here, both of our static functions, remove extra spaces and reverse words, are available as blueprint nodes. Even though we never created a blueprint class or object, I drag the reverse words node onto the graph. To test it, I'll type hello world into the input string pin. Then I connect the return value pin to a print string node so we can see the result in the output log. Finally, I connect the pressed pin from the W key event to the reverse words node and from there to print string. After compiling and saving, I press play. Now, every time I press W in the viewport, Unreal runs our static function and prints the reverse string world hello to the screen. This proves that our static C++ blueprint function works globally. We didn't have to create a new blueprint class or actor. These nodes are available everywhere in any blueprint as soon as the project is compiled. This approach is perfect for utility logic you want to use in multiple blueprints, such as string operations, math helpers, or data conversion, without needing to set up inheritance or custom objects.